Section 2.1 of your textbook introduces the topic of solving equations. Remember that an equation is a mathematical sentence containing an equal sign. And a solution of an equation is a value for the variable that makes the equation true. To solve an equation means to find all the solutions of that equation. So mathematicians often write solutions in set notation. A simple equation, like x plus 3 equals 2, may have only one number in its solution set. The number -1 is the only value of x that makes this equation true. In the same way, the equation 5n equals 30, again, has only one solution, the number 6. However, it is possible for a solution set to contain more than one number. The equation a squared equals 16 actually has two solutions. Both -4 and 4 are values that would make this equation true. The next equation, x times 0 equals 1, is an example of an equation having no solutions. There are no values of x that would make that equation true. Therefore, the solution set is called the empty set. Finally, the equation x times 0 equals 0 actually has an infinite number of solutions. Any real number times 0 equals 0. So the solution set for this equation is the set of all real numbers. Equations that have the same solution set are called equivalent equations. Let's look at the 5 equations in the middle of the slide and discuss which ones are equivalent. The first equation has a solution set that contains one number, the number 7, since 7 plus 3 equals 10. We can also see that the solution set of the second equation contains only the number 7. 7 minus 2 equals 5. Since 4 times 7 equals 28, the third equation also has the same solution set. The fourth equation, however, has a slightly different solution set. Both -7 and 7 are solutions of the equation x squared equals 49. Finally, the fifth equation, x equals 7, has only one solution, and that's the number 7. So as we compare the solution sets, we can see that there are 4 equations that have exactly the same solution set. These equations are called equivalent. The equation x squared equals 49 is not equivalent to the others because it has an extra solution, -7. Even though it has 7 as a solution, it does not have the same solution set as the others, and therefore it is not equivalent to them. Now, as we compare these 4 equivalent equations that have been circled, most people would say that the last equation, x equals 7, looks the simplest. And that's because the variable is alone on one side of the equal sign. Sometimes we say the variable has been isolated in an equation like this. This is an important idea because the process of solving equations is basically this. Continue writing simpler and simpler equivalent equations until you find an equation for which the solution set is obvious. And it can't get much more obvious than that last equation on the right, when the variable has been isolated. So let's discuss this idea a little bit further. To solve a linear equation, use the addition and multiplication properties of equality to write equivalent equations until the variable is isolated. Now, what are these addition and multiplication properties of equality? Well, the addition property of equality, stated algebraically, is that for any real numbers a, b, and c, the equation a equals b is equivalent to the equation a plus c equals b plus c. To put this another way, the addition property of equality says that the same number can be added or subtracted on both sides of an equation without changing the solution set. This allows us to add or subtract a number on both sides of an equation and obtain an equivalent equation. The multiplication property of equality states that for any real numbers a, b, and c, with c not equal to 0, the equation a equals b is equivalent to the equation a times c equals b times c. This property basically says that the same non-zero number can be multiplied or divided on both sides of an equation without changing the solution set, thus creating an equivalent equation. Let's look at some examples of how these properties can be used to solve linear equations and write their solution sets. In the first example, we have the equation x plus 17 equals 8. In order to isolate the variable x, we need to either add negative 17 or subtract 17 from both sides of this equation using the addition property of equality. Since 17 minus 17 is 0, the left-hand side of the equation simplifies to just x. The right-hand side of the equation is 8 minus 17, or negative 9. Now that we have the variable isolated, it's obvious that the solution set for our equation contains only one number, the number negative 9. The second example, y minus 2.5 equals 1.6. In this case, to isolate the variable, we will add 2.5 to both sides of the equation, again using the addition property of equality. Since negative 2.5 plus 2.5 equals 0, we have just y on the left-hand side of the equation. And then adding 1.6 and 2.5, we obtain 4.1. So the solution set contains the number 4.1. Moving to the third example, negative 3 times a equals 24. In this case, since we have multiplication in our initial equation, if we want to isolate the variable, we will divide both sides of the equation by negative 3. Note that dividing negative 3 by negative 3 produces a value of 1. And 1 times a is simply a, so we've isolated our variable. And on the right-hand side, 24 divided by negative 3 is negative 8. So we can write our solution set. Finally, in example 4, we have the equation 3/4 n equals 9. We can think in terms of dividing by that fraction 3/4, or in terms of the equivalent process, dividing by the fraction 3/4 is equivalent to multiplying by the fraction 4/3, which is its reciprocal. Now to perform the multiplication, notice that on the left-hand side, we have a value of 1n, so n has been isolated. And on the right-hand side, we can simplify and then multiply 3 times 4 to obtain our solution set. Now you should practice this process using the 4 problems on the slide. Once you've obtained your answers, you can restart the video to see the answers. In problem 1, we need to subtract 12 from both sides of the equation. The solution is negative 19. In problem 2, we need to add 2/3 on both sides of the equation. Find a common denominator. Perform the addition to find the solution, negative 1/6. In the third problem, we'll isolate the variable by dividing both sides of the equation by 9. And in the fourth example, we'll multiply by the reciprocal of 5/8 on both sides of the equation. So the solution is 16.